Today, this is a two-day lesson. We're going to talk about graphing linear functions. How can I know, this is the essential question, how can I know if a function is linear and how do I graph it? Please write that down.
All right. So functions are a constant rate of change, and that is called a linear function then. So really the rate of change is just your slope.
Correct.
Whatever that fraction is, that's your rate of change.
And we will talk more about that later. So let's first of all answer part one of our essential question. Determine whether the data set represents a linear function. So again, let's go back to what Ms. Boyd just said. A linear function means you're going to have a constant rate of change.
So the same number between your two numbers.
So what we're going to do is when we're given a table here, we're going to look to see how are our x values changing.
Okay.
So let's draw a little arrow. They're going up by 7. And from 11 to 18, they're going up by 7. And from 18 to 25, they're going up by 7. So far, so good. We're constant.
That's our x's.
So let's see if our y's are constant.
Remember, f of x is the same as y. Okay.
So we go from -6 to -15. That's going down by 9.
Okay.
-15 to -24 is going down by 9.
So they're the same so far.
And -24 to -33 going down by 9.
All right.
There we go.
Good.
So if we were going to write that as a slope, right? Fraction, we'd have our change in our y's, which is -9. So we'll maybe write change in y over change in x. So a change in our y's is -9 all over a +7.
Now remember, the y goes on top because we're doing rise over run. And I like to write rise with a y, so I remember y's are on top.
I like that, over run. So the answer is determine whether the data set could represent a linear function. Yes, it is linear.
Woohoo!
All right, example number 2. Let's do the same thing.
Again, so from 10 to 8, we went down 2. From 8 to 6, we went down 2. So far, so good.
Yeah.
6 to 4, we went down 2.
Right.
All right. But you always have to check
the y's
values.
also.
So there's our x's, there's our y's. So here we went down by 2.
Right.
Good. Here,
we went down by 4. And then we went down, and we don't have to keep going, actually. We can just stop.
Once you don't have a same number, you stop.
It stopped. It's not linear. Well, look at this. Miss Boyd already talked about slope of a line, and look at what else. It tells us the slope is m. That's our m value.
Okay.
And it's rise over run.
Again, you can always write it R-Y-S-E.
Yes.
So you remember y's go on top.
Yes, and I'm good with that.
Right.
And that is the same as our change in x, change in y over change in x. So if we're going to talk about positive slopes versus negative, Miss Boyd's going to draw us a little picture here.
So I'm going to pretend our slope is 3 over 2.
Okay.
So here's my line.
Right.
I go, oh, why did I put 3 over 2?
I don't know.
It's been a long day already. All right, 3 over 2. So I go over 3. 1, 2, 3, because those are positive. And I need to go up 2.
Right.
So over 3, up 2. I put my dot here. Since it is positive, we always read like a book, left to right.
Right.
So if I'm going from left to right, positive means we're going up from left to right.
Correct. There we go.
And it's a constant rate, so it's a straight line. Yours should be a straight line. Mine's hard to draw a straight line.
Right. Can I just ask a really quick question?
Yeah.
Did you just use an arbitrary point over 3, up 2? You didn't have it go with the slope, because typically when we're talking slope, it's really up 3, rise right from a point. So I want to make sure they didn't get
0.
Okay.
So if we start at 0, 0,
you're going to go
over 3, up 2.
But it's really up 3 over 2.
Oh my goodness. You're right, Miss Young. Ha!
I just wanted to make sure, because I was getting a little confused.
Yeah. So always pick a point first.
So let's say we pick the point 0, 0.
So we're picking 0, 0.
But remember, if it's rise over run, it's going to be up 3 over 2.
All right.
There we go. Okay.
That makes
I just was confused.
I was too.
Okay. So we fixed it.
All right.
Now let's talk about negative slopes. So should we have our starting point be 0, 0 again?
Okay. So I don't get confused. All right. 0,
And
0.
how about we use negative 1/3?
All right. Doesn't matter where the negative goes?
No.
No, as long as you pick just one of the numbers to put the negative on.
Correct. So let's
All
draw
right.
our graph again. Start at 0, 0.
So we're starting at 0, 0.
And we're going to go down,
Down
1
1
to the right 3.
There we go.
And we draw our
And
line.
we draw our line.
And it's going down and to the right.
Yes.
There's an example of negative slope.
Awesome.
So if we go on to example 3 here, graph the line, tells us the slope is 5/2, and it's passing through the point negative 4, 2. So right away, you should know when you see a positive slope, your graph is going to go up and to the right, for
Something
sure.
like that.
So let's plot our point.
Here's our point.
Negative.
We don't just start anywhere this time.
No.
It actually tells us. So we're going to go back 4. 1, 2, 3, 4. And
Up 2.
1, 2.
There's our
Put
point.
it out there.
Now we're going to do rise over
That's
run.
where we start.
So we go up 5 over
5.
2.
So up 1, 2, 3, 4, 5.
And over 2.
1, 2. And when I say over, it's positive, so we went to the right 2.
But let's now do the other direction. Let's start at that point again. We can also go
Because we can always go
down
negative,
5
negative.
and down, or excuse me, and to the left too.
Because the negative over negative is positive.
Right, so down
1,
5.
2, 3, 4, 5.
And to the left 2. And if we connect,
Oh boy.
here we
Good luck
go.
To me,
We're gonna
but you guys can do it a lot better.
There we go. But it should go through all the points.
Yes.
Example number 4. Should we go and do that one?
Yeah, that'll be good.
All right, so now you have a negative slope. Your
Okay.
graph better go down and to the right. Down and to the right.
Down and to the right.
We'll try that again.
Oh boy, here we go.
Down to
There
the
we
right.
go.
There!
All right.
So the point
we
is
started
3,
at
1.
1, 2, 3, up 1.
And we go down
Down
1 to the right 4.
And you could
Down
go
1 to the right 4.
Oh boy.
Oh boy.
So I'm
Let's
going
go.
to switch this to 1 over negative 4.
So we go up
So
1
we'll go up 1
to the left 4.
1, 2, 3, 4.
Right.
There we go.
And let's connect it. Here we go. Good luck. Wish us lots of luck here. Oh! Okay. You guys get what we're talking about. Let's go on to. Oh, so we have not talked about this yet.
No.
We're going to talk about x-intercepts and y-intercepts. And basically, what that means is, if we look at, for example, let's just look at one of them. Let's look
Okay.
at the x-intercept.
All
What
right.
is that point? Let's write the point.
All right, let's write this point. And I noticed we go over 2,
Correct.
but we don't go up or down.
Right.
So 2, 0.
Exactly. And always your x, when you're finding an x-intercept, your y value is always going to be 0
Yeah.
because an x-intercept is the point found on the x-axis.
That makes sense.
Y-intercept is the point on the y-axis.
So no matter what, without even looking, if it's a y-intercept, I know that my x is going to be 0.
Always.
So then I can go over 1, 2, 0,
There
2.
we go. So we
Alright.
have, yep. So if it asked us, what is your x-intercept? You would say the x-intercept is 2.
2.
Or you can write it as a point, 2, 0.
Okay.
So let's do example number 5. Find the intercepts of the graph and graph the line. So remember what we just said. If you're finding, let's start with x-intercept. If you're finding the x-intercept, we know something about y. Y is always
The y
equal
is
to,
0.
right. So that's what we're going to do. We're going to plug in 0 for y and
Okay.
solve for x.
So we get 4x minus 2, and we
Right.
plug in 0 for y.
Right.
Equals 16.
Mm-hmm.
So I get 4x, well that cancels. Equals 16.
Right.
Divide by my 4. X just equals 4.
Right. So that is, so we found our intercept. So what we probably should do is write that as a point.
Yes.
So we're going to need that. That's going to be the point
So we
4,
know-
0.
Yes, the y was 0, and then we found x, which
Mhm.
was 4.
That is our x-intercept. Our y-intercept, same thing, but now we're going to set x equal to 0.
So then the x equals 0. I'm going to kind of just sort of draw a line here. So I know
Yeah,
it's
like
right
that's
there.
a good job.
All right, so now we're going to plug in 0 for x.
Mm-hmm.
So we have 4 times 0
Minus 2y. Yep.
equals 16.
Correct.
Well, that 4 just disappears,
Mhm.
and we're left with negative, don't forget the negative, 2y equals 16.
Divide both
by
sides by
negative
-2. And you're going to get y equals -8. So now,
Again,
let's
we
give
wanna
us a
write
little
our
bit
point.
more room
Yeah,
here.
Thank you.
Our point is going to be 0,
Comma, negative 8.
Right. So if it says graph, the directions, if you go back and look, were find the intercepts and graph. So really, to graph this, we have 2 points. We're going to plot them.
Perfect.
So
I'm going to plot 4, 0. So I'm going to go over 4, 1, 2, 3, 4, and not up or down any.
Right.
And then 0 means not left or right, but down 1, 2, 3, 4, 5, 6, 7, 8.
And all we're going to do now is connect the dots. Oh, boy.
We're going to sure try.
We're going to sure.
Oh. Almost.
Pretty close. Okay. So that's how you graph using intercepts.
Okay.
Do we want to do example 6?
I think we'll just skip it and do it in class.
All right. So there's example 6. And look at that.
There's your video question for the day.
We will see you tomorrow.